Good afternoon and welcome to the webinar. This webinar is about asphalt pavement maintenance, and we're going to specifically be looking at a couple of the most common things that we do in terms of maintenance, which are filling potholes and sealing cracks. So that will be the main topic of discussion today. This is an Arkansas Local Technical Assistance Program sponsored webinar series. This is part one today. Part two will be next week on Thursday afternoon, and that will cover some treatment options that are kind of above and beyond the typical potholes and cracks topic. Just want to touch base in case you've not been in one of the go-to webinar type trainings before. You do have a control panel to adjust how you're seeing and listening to the webinar. You have the little control panel that will expand or collapse with the orange box and the arrow. Everyone is currently in listen only mode. You have the ability to go full screen or to undo that full screen. That will toggle back and forth. And so if you are not in full screen mode, you can also adjust the zoom, and that will kind of tweak your view so that you can look at the slides in the best aspect ratio. There are some audio options. It looks like most of you are attending using your computer audio, which is great. If something happens during the webinar and you're not able to continue that, there's a phone call option where you can call in and continue to get that audio. There is a handout for this webinar. It's basically the presentation that I'm going to be presenting today, so you can click that to download a copy, and you're welcome to share that. And then I would also point your attention to the questions pod. Anytime you have a comment or a question, something that you would like to address on this topic, just feel free to pop that in at any time, and we'll be stopping periodically to answer those questions. If you have a chat pod, you're welcome to use that too, depending on your computer and your version and device. You may or may not see that. My name is Stacy Williams. I'll be your instructor this afternoon. I'm the director of the Center for Training Transportation Professionals and faculty member at the University of Arkansas in the Civil Engineering Department. We also have Tally Faulkner. He's online with us, providing technical support and handling any issues that come up during the webinar. Also, if you have anything that comes up, you can email us at arltap@uark.edu. and that will get information to both of us. For this webinar, it's a 2-hour session this afternoon. You will be getting credits toward the Road Scholar program through Arkansas LTAP. This one will be 2 hours of Road Scholar credit. You will get a certificate. It'll probably be mailed next week, and you do have to attend the full webinar to achieve that certificate. Now, I know several of you are attending as a group. So after the webinar, if you would just shoot me an email at that ARLTAP web address and let me know all of the folks who are attending with you. You send me that list of names, and we will make sure that everyone in attendance is able to get credit for that and get the certificate. I also want to point out Patrick Thomas. He is the program manager for the Arkansas LTAP program at RDOT. And if you have any questions that pertain to him, anything about the program in general, he would be the guy to contact. So, and then we do have more information on our website. That web address is shown there, cttp.org/ARLTAP. Now, to start out this afternoon, I would like to ask you a couple of questions. The first one is, that's going to show up as a poll on your screen. So if you are attending as a group, you may have several answers, but this one is a select all that applies. So I want to know, what is your role in asphalt maintenance? Select everything that applies. You might be a crew member, crew leader, foreman, superintendent, decision maker, or just a traveler. All right, I'm going to go ahead and close that, and I can share the responses with you. We have some who are crew members. We have even more who are crew leaders. We have some foremen, superintendents, and we have a good group of decision makers, which is wonderful. So glad to have you on today. And then we have some who are travelers. I think technically we are all travelers on these public roads. I'm going to put that one away and put, see, this next slide should come up now. Okay, how do you describe maintenance? And this is something I would like you to type and answer in the questions pod. So if you are attending as a group, just designate one person who can type in those answers for you. But what is it? If you think maintenance in your day-to-day type job, what comes to mind? So what is a description? How would you explain to someone very quickly what you do in terms of maintenance? All right, good answers are coming in. Procedures to increase the life of our roadways, absolutely. Methods by which service life can be extended with less effort and cost, very good answer. We're always trying to do more with less. We have limited funding to do the things that we do in terms of maintenance, so we always want to do that with less money and be able to be more efficient with what we have. Maintaining our roads to keep them functional and safe. The actions that we take to preserve pavement life, preserving good quality and extending service life, great. Pothole repairs, absolutely. We definitely do a lot of that. Okay, and then identifying current and upcoming needs. That's kind of the crystal ball, the forecasting of figuring out what's coming later and how do we manage that with the things that need to be done right now. Very good. All right, so maintenance, if we were to put a definition to it, you could say it's repair to keep something in working order. In the context of what we do as a public service agency, we're going to continue to service the traveling public. So we have folks in the world that need to get from point A to point B, and it's our job to make sure that they can do that functionally and safely. There are some other things, though. We might have something that's thought of more as like corrective maintenance, and that is where we would fix a problem that has already happened. So something happens, we have to put it back like it was, and that's going to be a little bit different than preventive maintenance. Preventing something from occurring is doing it in advance. So we're fixing a problem, but that problem has actually not yet occurred. So a little bit different strategy. And then preservation is just one step further in that thinking ahead mindset where we're doing things in advance to keep those problems from ever occurring at all. And of course, we would want that to be our main goal, but I think in reality, we know that we can't always do that. So maintenance can be planned, which would be proactive, or it can be unplanned, which is a reactive type of setting. So in those two different mindsets, we have some control over things in the proactive setting, specifically the timing. If I can plan ahead and know that something is coming, I'm going to have to do these things, which would kind of be along the lines of the preventive maintenance. It's something that's going to probably happen, and I'm going to do something to prevent that. I have more control over the timing. In other cases, maybe we have a big storm, we have some things that go very badly, we need to put things back together. I don't have a choice on the timing. I have to do something very quickly. If it's a case where the functionality of that roadway is suddenly not there, I have to put that roadway back in service as quickly as possible for the travelers. In terms of budgeting, same kind of thing. If I can be proactive and think ahead, I have a lot more control over how I use those portions of the budget. We, of course, have unexpected things that happen. We don't have a choice. We have to find the money somewhere to fix this problem or put this bridge back, put this roadway back in service. And then weather. Weather has a huge impact on the quality of the work that we're doing. If we are able to plan ahead and look at the weather forecast and perform those maintenance actions in the best possible weather, we've got better conditions. They're going to last longer. I'm going to have better results. If I have to do something when it's raining, you know, it's not optimal, but I've got to put this pavement back in service. This is how I'm going to do that. I also know that doing that in those not so optimal conditions means I'm probably going to be coming back to do that again pretty soon. but we don't have control over the weather. We can't wait for a better day. We just have to get it done. I can coordinate resources better if I can plan ahead. Unplanned, reactive type situations, I don't have the opportunity to do that. So you can see on the unplanned and the reactive side, things cost more money. We just have to drop everything and go fix that thing. Money doesn't grow on trees though, so anything we can do to shift toward a more proactive setting, that's going to help us be more efficient with the dollars that we have. Now, to figure out how to fix something, we need to understand what's causing it to fail. So why do asphalt roads fail? On the picture here, you can see pavement chunks are missing. And this is on a roadway that's got a thin section of asphalt as a surface. And there was a very, very large rainstorm. Water came up over the roadway, and water is very powerful. So when you have those types of storms, it's sometimes too much for that roadway to withstand. And you can see lots of pavement chunks over here on the right side of the picture. They are off of the roadway completely. So this is the kind of thing that was really somewhat of a catastrophic failure. I'm going to have to go out and fix that very quickly. I need to return that to service. But looking at what causes some of these problems to happen, obviously traffic puts a load on the pavement. That's going to cause some failures. The weather has a huge impact on how things behave. The subgrade, that's our foundation, our support structure that's going to hold that roadway up. The materials that go into that asphalt pavement, that has an impact on how long it's going to last, how well it's going to perform. The design, when we look structurally at that pavement and what it has to support based on the foundation that it has, that's going to tell me how much thickness of asphalt I need, as well as those other pavement layers. And then construction techniques. And this really is very similar to things that happen during maintenance projects as well. So construction techniques need to be the best possible thing that they can be. When we do maintenance, we also need to be very careful to use those best practices, because we don't want to do something to mess it up and make it not last as long as it should. Now, some of the types of failures that happen, most of asphalt failures are going to fall into two categories. That's either going to be cracking or rutting. So there are a number of different types of cracking. We might see some directional cracking. That would be longitudinal in this photo. The next picture shows some transverse cracking. And then we might also see a combination of both of those. And that tends to happen when we have one or the other. Eventually they kind of get together and they start to connect. Once those areas have connected cracks, we now have a weak spot. And anytime there's a crack, that is a break in the pavement. That allows air and water to get down into the pavement structure, and that is really the mortal enemy of any pavement. So allowing water to get down in that structure is going to cause everything to deteriorate more quickly. So over time, we've got these connecting cracks, and you can see there are some other random cracks that are starting to develop at that intersection. And that's eventually going to turn into something like this. So we get a pothole because we've had those connected cracks. And once those cracks separate an individual piece of asphalt, it's no longer a cohesive part of the mat. Now it's just loose. It's sitting there. And at some point, we're going to get enough traffic or enough water on the roadway that it's going to just fly out of there and be gone. Now we don't have anything in that spot. And we all know, we get calls, we get complaints. No one likes to drive on a road that has potholes, and they call and they want that fixed like yesterday. Okay, so here are some other connected cracks, some types of failures that we might see. One thing to notice though is we have fatigue. We also have some that's more related to weathering. So pay attention to where the cracks are located within the pavement lane. In the picture here that you see, there are some cracks. It looks like it's kind of concentrated in the wheel path. That's going to tell us that the load that's placed on this pavement by traffic is really the driving force in what's causing the cracking to happen. So when it's concentrated in the wheel path, that's going to be more of a structural issue. And if we just see kind of these random here and there sort of cracks that go different directions, that's going to be maybe an aging or weathering type of thing. Those can also become structural failures, but they maybe didn't start out that way. But as those cracks start to connect, they become more and more connected. The pieces start to become smaller, and we see something that's called severe fatigue cracking. You probably call it alligator cracking because it does look like alligator skin. And so this is the phenomenon that we see, and we know that that is our next pothole. So that severe fatigue cracking is a pothole waiting to happen. You know you're going to have to go there and do something. If that is in an isolated location, it might be a very small pothole. Sometimes it's a large length that is starting to behave in this way. But one thing to look at this picture. We've got all of those cracks. We've got the small pieces. The smaller the pieces, the more cracking we have. And there are even some places, if you can see my cursor, there are some places where you can tell those small pieces of asphalt have popped out. They're already gone, which means I have even less lateral confinement for these others. They're much more likely to move. It's not going to take a whole lot of traffic to pop those out of there. So we've got our pothole starting to form. The other thing I would point out is that it's wet. When you have a pothole, that creates a low spot in the pavement. Water runs downhill, so we know that that's where water is going to concentrate. Water is the worst thing we can put in our pavement. So we've just created a place that water wants to go and it wants to stay. It's going to do more damage now. So we see that deterioration process really start to accelerate at this point. Now, when water enters the pavement structure, again, we've got those open spaces that are a collection point for water, but we also have traffic on the road, which is pushing that water down into those cracks, into that surface. So when those open spaces exist, water is being forced down into the pavement so it can permeate the structure, not just the asphalt surface, but also the crushed stone base, down into the subgrade. We've got all sorts of issues going on there. We might start to see something like this. So we've got cracking. It's definitely severe fatigue cracking. You can tell along with that the surface has changed in terms of the cross section. It's no longer kind of a straight line across horizontally. We've got a low section that's in the wheel path, and then you can see where that's been pushed down. We're collecting water. Next to that, the pavement has actually been pushed up over the curb. So all of that is broken. It's in bad shape, and it's going to sit there collecting more water for a longer period of time, and this section is going to deteriorate much more quickly. Now, the other thing that happens, not only do we have water going into the surface and getting into that underlying structure, once we have water that has kind of soaked in and is sitting there, now we're going to have traffic passing over, and that's going to change, kind of press down, and then the pavement surface will go down and will come back up a little bit, which creates a phenomenon known as pumping. That means we're going to pump the water back out of that pavement structure, but the problem is it's not going to just be water. It's also going to be little bits of our subgrade that will come back up through those cracks. So once we're pumping subgrade material out of the structure, now I have a void space underneath, and I've completely lost that bit of support that was there. So pumping will tend to look something like this. It will look like the pavement is dirty. There are certainly cases where the sediment can run from something off-site, run onto the roadway, but a lot of times when we have this low spot, it's a complete base failure with loss of support. We're actually pumping subgrade material back up through to the surface, and it just looks like the roadway is dirty. That is your foundation that is no longer in the foundation location. Okay, so once we lose that support, our profile is damaged. We also get a lot of roughness. So once you have all the broken pieces and those differential elevations, as you're driving over it, it's a rough road. So when you get to that low spot, you hit kind of hard. That's already the weak point. And now our vehicle is actually changing and increasing in impact on that weak point. So we see all of that. We start to push water back down into the surface, driving on it more, pumps the subgrade back out. And again, this really just accelerates that deterioration cycle. Now, if we don't repair these failures, obviously they're going to get worse. And so we see lots of things in comics and newspaper, stuff on the news. It's kind of a big deal because it gets a lot of publicity. And we are typically working in public service type entities. It's our job to provide this service, and no one notices when we do it right. It's rare that you get a call or a letter or email or anything saying, hey, great job, that road is super smooth, I really like that. We get the calls when something is not good. And so we get the bad end of that all the time. So anyway, at this point, are there any questions to be addressed?
Hey, good afternoon, everyone. At this time, we do not have any questions. As Stacy alluded to earlier, please feel free to get those questions posted on the questions pod, and we'll get to them as we move along.
Very good. All right, so let's talk specifically about pothole patching. You've all probably seen some exciting potholes in your area. Maybe not. If not, that's actually a great thing. Sometimes they're big enough to go fishing in. And the picture on the left is just something from social media that was funny. But the picture on the right is from the actual Little Rock newspaper a number of years ago. And there is a car. Now it's utility work, but still a car actually went down in the hole. And we don't want that type of thing to happen for sure. So we got to fix those potholes before they get that big. The other thing that we see in the news is how much it costs, and it's usually not focused on how much it costs the agency, but how much it costs drivers and vehicle owners, because all of the rough roads and the potholes lead to vehicle damage, and that generates a lot of publicity. It's not good publicity, but it is expensive when our roads are not in good condition. They do deteriorate more quickly, but the driver has costs in terms of vehicle repairs. You can have blown tires, you can have scuffed wheels, you can be out of alignment, all kinds of things. And there was an article back in 2017 in Jackson, Mississippi. They had an estimated cost of deteriorating streets costing drivers $2,000 a year. Now that was 2017. And I can tell you that the cost of tires has just about doubled since then. So that number, I'm sure, is much higher at this point. So the drivers have to assume some costs. Not really their fault, but it's part of the deal. But the agency is certainly having to absorb costs because that pavement deterioration is a loss of value in the network. It's also extra costs in terms of how much maintenance has to be done. And then that is really turned back to the taxpayer because of that overall network value and the tax dollars that are going to support those maintenance activities. So I'm going to pop a poll question up here for you. How much do you think it costs to patch a pothole? And if you're in charge of this, you may know exactly how much it costs. So $20, $50, $100, $500, $1,000. Very good. Looks like most of those answers are coming in. I'm going to give you just a couple more seconds. All right, I'm going to close that poll. I'm going to share those responses. And it looks like the majority would say that a pothole costs about $500 to fill. Truthfully, it depends. Depends on how big the pothole is, how thorough your methods are for how you're going to repair those. But I think by and large, somewhere in the $100 to $500 range is probably very accurate. If we do something a little more substantial, like a deep patch, we're going to be up in that $1,000 or even more money than that. All right, I'm going to hide that one. Give you one more. How long do you think a pothole patch will last? A few weeks, few months, a year, several years? All right, very good. I'm going to close that one. Looks like most of you said a few months, maybe a year. We have a few of you that said it lasts several years, and I would love for you to comment on how you do your pothole patching procedures a little bit later. So very good. I'm going to hide that. We'll go back to the presentation. So we see a large variety of potholes. We see some that are very small, but if they're in the wheel path, that's still a big deal. And it's not just a big deal from, tires and alignment and that type of thing for the driver, but also if you drive on a road regularly, say every day on your way to work, you go down a road, you know where the potholes are. You drive it frequently and you know just where to swerve to avoid that pothole. If you happen to swerve into oncoming traffic, then that's a big deal. Okay, that's a safety issue. So aside from just the mechanical problems that we might have in vehicles and the pavement deterioration, there is a personal safety aspect that we can tie to this as well. Okay. Oh, and one other thing I would point out, this picture on the right has the big pothole here. It's full of water. That is another thing that makes a pothole very dangerous, is because when it's filled with water, you don't know how deep it is. It might be 1 inch deep, it might be 6 inches deep. And when you can't tell that, sometimes we don't make the best decisions as drivers. All right, so along the lines of our how much does it cost and how long will it last, what I will tell you is that you really can assign a cost of a pothole patch and relate that directly to how long it lasts. The longer it lasts, the cheaper it really was over that certain length of time. And your level of success with those patches is going to depend on the effort that you put into the repair. So there are lots of ways we can do this. We can do something very minimal, just throw and roll, throw and go. We might do kind of a medium level of difficulty with a semi-permanent type patch. And we might really go all in and do a deep patch and really fix this thing from the bottom up. What we decide to do depends on the location, the traffic, weather, water, and the resources that we have available. But really the cost of a pothole patch is mainly a function of how long that patch is going to last. If you do something that's very inexpensive, but it doesn't last but just a few weeks, and then you're back out there doing it again, you're having to spend more money on that same location over and over and over. And that really makes the price go up. So what are the basics of being able to patch a pothole? Well, first of all, we want to clean it out. Then we've got to fill it up. Then we've got to compact that material in place. Okay, so first of all, cleaning. We want to remove the water and the loose particles. We want to make sure that that new material is going to stick. So if I have a really dusty coating or lots of crumbs and dirt, debris down in that hole, and I just put in patch material on top of that, it's not really going to stick to the solid material that's down beneath that. We need it to bond, we need it to stick together. We can use a broom, we can use a mop. A lot of times, like we've seen in these pictures, our potholes are going to be holding some standing water. We need to get that out of there. That water will prevent the bond between the new and the old material, so that needs to be cleaned out. And we can use a blower to help do that as well. Okay, next we're going to fill it with material. So grab the shovel, get some mix. We want to distribute that evenly throughout the entire pothole. We want enough mix to slightly overfill that spot so that after we compact it, it's still going to be full. And then it needs to have a shape so that it will shed water. So we need to compact it. That's going to help us provide a more solid surface. And when I was saying about not holding water, we've got to have enough material that we compact it and let some traffic on it and still be able to have a slight crown. That's going to shed water and keep water away from that spot that we know is already a weak point. Okay, so is this good enough, do you think? We've taken our broom, we've swept this out, we fill it up with material, and then we drive over it, and off we go. So it's not that hard, doesn't take that much time. Is that good enough, do you think? Well, that is one of the minimal methods. We call that throw and go or throw and roll, which means we kind of roll over it with the truck as we drive away. But again, very minimal. That also is going to be something usually very, very temporary, but it's least expensive, least labor intensive. I can make a lot of progress on this type of thing and address several locations in a short amount of time. But if it doesn't last that long, is that really worth it in the long run? Well, it depends. Let's see what our conditions are. If I'm having to go out and patch, say, a pothole, and it's been raining, everything is wet, maybe it's really cold out, that's not really optimal conditions for being able to provide a suitable repair. So I don't want to spend a lot of money on something that's going to have to happen in not our best case scenario. So why spend money on that? Perfect time to do some throw and roll, but knowing that to really fix it, I am going to have to go back later and do that again. So kind of in an emergency situation, there was one morning, this has been a while back, and on my way to work, it was raining so hard, and traffic was backed up, and I thought maybe there had been a wreck. But when I got up around the curve, I saw there was a truck pulled over on the side of the road up on the curb, and they had cold mix in the back of the truck. And the guy was standing in the back of the truck using the shovel to throw the mix out into the roadway into a pothole. When the mix hit the pothole, water was sloshing out. Well, that's not good. We're not supposed to have this mix going into a puddle full of water. That's not going to stick. It's not going to be there long term. But two things stuck out to me. This is rush hour. It was a pretty good sized pothole. So bad situation, bad timing, something needed to be done for safety purposes. So they did get that filled in. Also, super impressive that he was able to aim and actually get the mix in the hole. He was probably 10, 12 feet away, and he was just tossing it right in there. So I was impressed by that as well. But we know that's not going to be a long-term solution. That was something to get us through that storm system, that day's rush hour traffic, that type of thing. Another time that you might want to make sure that you don't spend a whole lot of money on something or a lot of effort is when you have an upcoming rehabilitation. If you have a roadway with a lot of potholes, sometimes that's on our list of things to be repaved or maybe reconstructed, some type of major rehabilitation. If you're about to do that anyway, why go to the effort of doing a really significant patch? Now, if you need that to be patched very well because all you're going to do is put a thin overlay over the top of it, then yes, absolutely. But if that's going to be mixed, it's milled, and it's going to go away soon anyway, don't spend a bunch of money and time on it. Okay, so those are the minimal methods. Let's say that this is going to be out there for a while. We would like for it to last, so we want to do something that's a little bit better. That's when I would move to what we would call maybe a semi-permanent patch. This is a higher quality pothole patch. It's very effective for localized failures, but it is more expensive, takes more equipment, more personnel, more time. And when you're out on the roadway for any length of time, you definitely need to make sure that you're following the requirements for traffic control. Putting up signs, maybe you've got a lane blocked off for a period of time. Think that through and make sure that you have all of those safety and work zone safety things put together. To start with, we're going to take our pothole area, mark out the boundary, and we're going to actually cut not just the pothole, but we're going to back up from that a little bit. We want to completely encompass that deteriorated area. We're going to cut that out using right angles, so that means we're going to cut a square or a rectangle, and then we need to make sure that that hole is large enough that we can fit our compaction equipment in that space. So if the blue area is our pothole, then I'm going to go outside of that and mark out a nice rectangular shape. That's going to be what I cut out of the pavement. That way I'm back to hopefully what would be considered good material. So cut that square boundary with something like a diamond saw. You can use a pneumatic hammer with a spade bit. Milling equipment works. I would use whatever power equipment you have available. I'm basically lazy, so I think the easier you can make it on you and the quicker you can get it done, but use what equipment you do have available. We want to make sure that we're cutting this as much as possible to have vertical faces where we don't damage those faces. We want to keep nice clean edges. We also want to go to a depth that is 50% deeper than the failure. So sometimes it's hard to tell, but sometimes we've got a 2-inch overlay that's deteriorated. What was under it is actually in better shape than what's on top. So if I have a 2-inch overlay and that is just that layer that had the pothole, then I'm going to cut at least 3 inches deep, so 50% deeper than the failure. Sometimes we get into a situation where we're digging down into the base layer, and sometimes we have those really deep failures where we're cutting way down into the subgrade. And if it's the subgrade that's actually causing the issue, it's hard to know when to quit. So 50% deeper than failure is optimal. You do have to use some judgment there. You can't go forever, but do what you can. We'll talk about that a little bit more on the deep patches. So here's an example of a spot that we've obviously had some alligator cracking, that pothole is formed, and we need to repair this spot. So we want to use right angles. We want to go outside the limits of that distress. So right here at the top right of the pothole area, you can see some additional cracking. So I don't want to cut right in here where the cracks are happening. That's still deteriorated pavement. So I'm going to move on out a little further where this dashed line is and get outside the limits of those cracks. And do the same thing on the top left side. And then across this bottom side on the left, we see cracking all the way through the picture. So we really can't get outside of all of that deterioration. But again, we got to make a judgment call. We have to stop somewhere. And if you look, these little broken pieces that are up closer to the actual pothole, those are very small. So we've got closer crack spacing, and then that starts to spread out a little bit. So at least get back here where you don't have such a close spacing of those cracks, and that's going to help us out. And we'll close that in on the bottom right. All right, here's an example. I would make a couple of comments on this. This is marked out. We have a nice square kind of a shape. This is an older patch that's been placed before, didn't last forever. We're having to do that again. So good technique. Last time didn't quite work, so let's move out a little bit further, make it bigger. The problem is, if we follow this paint line, we're not really going to intersect at the same section where this previous patch was done. We've got this crack sealing, and those don't line up. We don't want to create a small notch. That is a recipe for pretty quick cracking. So what I would do is move that on out and make it as wide as the patch that was done in the left portion of the picture. Okay, now we've got to cut out that distressed area. So use your saw, whatever type of material or equipment that you have, milling machines, that kind of stuff, whatever you can do to get that deteriorated material out of there. And then we need to make sure we get it all out. So it isn't a hole, shovel out what you can. There's going to be a lot of dust, dirt, and debris that's left on there. You might be able to use a backhoe, but definitely use some type of a broom or something where you can brush that clean. If you are cutting down through the asphalt and then down into the base or even into the subgrade, you can't truly get it clean per se because you do have those smaller particles. But we want to remove as much of that loose material as possible. The loose material is just going to be a barrier that prevents our patch material from sticking to what's underneath. Okay, again, make sure you remove any water. You can use a mop to blot that out. And if you use a wet saw to cut, you're going to want to blot that out of there as well. Asphalt materials and water are not friends, so we don't want to trap water down in that part of the pavement. Make sure the edges of your hole are clean and square. Okay, so again, we're removing all of that material. Make sure the edges of the hole are vertical. And if you're using larger equipment, like in the picture, then make sure you're not scuffing that up and kind of chewing up those edges. Sometimes they can get kind of ragged. That's going to make it a little bit more difficult on us to get a good patch there. but all those edges should be sound, and we don't want to create more cracking at the edge of the hole just from the power equipment that we used. Now clean that out, scoop it up. You can put it into a bucket, whatever thing you put it in, but you want to haul that away, make sure you dispose of it properly. And then again, we're going to brush that, get it cleaned off as best we can. That's pretty simple if you've gone down to just pavement, but if you're down into an area that's got more of the dirt and the aggregate, that's going to be more difficult. So sweep until it seems to not be moving a lot of material. You can also use a blower. That will get a lot of that loose dust out of that area. Okay, now what about the materials that we're going to put in the hole? Most of the time we're going to use cold mix, and that's because it's probably the easiest thing to work with. So it is most common. It is a temporary fix. I would say that the quality of cold mix is not as good as hot mix, but hot mix is a little more difficult to work with. The cold mix, it's not temperature sensitive. It's easy to store. You can get variable quantities. But what that is really just an aggregate and an asphalt emulsion combination. It can also be used in injection patching. So it's more user friendly. And for what we're doing, we're using a little at one place, then we're going to another place. We're using some more. But hot mix has to stay hot. So unless you have a hot patch truck, it's going to be difficult to keep it at the right temperature to get a good mesh and get it compacted in that hole. Now, if you do have a hot truck, then you can keep that material there. And this is a good idea to get some mix. And then you can have your route planned out for the whole day. Here's my map of potholes. Here's where I'm going to go. You could even have two crews where one works ahead of the other, gets it all prepared, swept out, saw what needs to be sawed. And then the hot patch truck shows up and the other stage is happening where we're filling it with material and compacting while crew number one has moved on to the next location to get that ready. This is something that's a great idea if you're doing utility cuts, same concept, same practices. So if you can use hot mix asphalt, it is going to be a better material that will last longer. You want to make sure that if you've ordered hot mix for this, that your top size aggregate is no more than a ½ inch. Probably smaller is better if you can get a 3/8 inch. So in super pave type terms, that would be a 9.5 millimeter mix. Remember that this stuff is temperature sensitive, so make sure to regulate the truck and keep that temperature right. Plan your times and your locations. Sometimes, even if you don't have a patch truck that keeps the mix hot, you might be able to get a small quantity. Say if you have a construction project over on one street, then 2 or 3 blocks away, while that project is going on, you could go over and grab some mix from the hopper of that paver and go a couple of blocks away and patch all the potholes in that area. So kind of thinking outside the box of how to coordinate and plan ahead to be able to get a better material for your pothole patches. If you don't have a construction project there or some other source for getting hot mix to the area, it's really not feasible to get hot mix unless you can keep it hot for a long period. All right, there are lots of special proprietary patching mixtures, and as a local agency, a lot of times I know you guys are approached by salesmen that have the greatest thing since sliced bread, and they have 10,000 reasons that you should buy their stuff. Some of it is wonderful, some of it not so much, but just be careful before you commit to purchasing some of this stuff. I would ask for some references, talk to some folks that have used it, or maybe look at your state DOT's qualified products list and see if it's already been vetted through another agency. But make sure that you are paying attention and you don't get snookered by something that's not going to work that well for what you're using it for. So make sure those bituminous materials are coming from an approved source. Now, some things that we can do to make this pothole patch even better would be to apply a tack coat. One of the big things is when we put that patch material in the hole, we want it to stay there. So anything we can do to glue that down wonderful. Do that. That is an added step. It's going to cost a little bit more. It's an extra product to have on site, but it's also going to stick it and help it to stay there for a longer period of time. The longer it lasts, the cheaper that pothole patch actually was. If you do this, you can use your emulsion. A rate of about 0.2 gallons per square yard is typically good. So you're going to spray that on or brush it. You don't want to pour a puddle of it down into the pothole and then try to spread it around. That typically does not work very well. Right, then once that's in place, you're going to start filling the hole with the patch material. You can shovel that in and make sure that as you're filling that hole, try to spread that mix around so that it's very evenly filling the space that you're trying to completely contain. So there's a little bit of an art to it, but if you are shoveling, if you are right-handed, if you're throwing the material, it's very common to kind of lump up in one area and then go back and try to spread it around. I would encourage you to try to place those shovelfuls in a more even pattern to start with. Pinch that into the corners, make sure that you're getting everything as evenly placed as possible. If you have clumps of material and then little spaces or divots in between, when you go to compact that, you're going to see differences in percent compaction or differences in the density, and it's not going to be as even. Then when traffic gets on that, those areas that were not as dense, they're going to kind of cave in on you a little bit. And then the parts that had more mix, they're going to be more sturdy. So you're going to have a lumpy patch. You won't see that for a while until traffic does its thing, but you will end up with some lumpy patches. So right here is where this starts, and being able to get that mix very evenly spread throughout the space of that pothole area. We also want to make sure that we have enough material that we overfill it so that when it's compacted, it's completely full, and we have just a little bit more than that to create that crown shape so that our patch will shed water. Okay, so as you are filling that hole, you want to pre-compact the patch. Turn the shovel over, shove it down in the corners, and especially if you cut out that square shape or rectangle shape, make sure you're getting mix pinched into the corners. You can also use a rake, but I would caution you on the raking, make sure and use the back of the lute where it's a straight side. If you use the teeth, what typically will happen is you drag across there and you're actually going to pull out those larger aggregate pieces, and you're going to segregate the mix. If it's cold mix, and especially if it's hot mix, there's a very particular gradation of how those particles are going to fit together so that the rocks fill in the spaces and create a sturdy aggregate skeleton. And if you rake out those larger particles, it's going to be hard for it to continue to have that stability. So try not to do that. Keep those big, medium, and small size rocks all mixed together very homogeneously, and make sure that it all looks the same. So it's not a good idea to rake, although you can use the rake to kind of push the mix around as a whole. Okay, the only time I would use the teeth is just to feather out the edges. Okay, so filling the hole, you can see on this, they've raked and pushed and pulled and prodded, and they've got it nice and even. This is before we've gotten to the compaction state, but everything looks very consistent, very even. That's what we're looking for. Now we're ready to compact. So we're going to compact that patch material. If we have a small roller, that is wonderful. That gives us a lot of compaction. We want it nice and tight. We want it pinched down into those spaces. 3 or 4 passes is usually good. If it's a large area that's being patched or something long and skinny like a utility cut, something like that, I would say a roller is a great, great, great thing to have. Make sure that your compaction equipment does fit inside the hole. So on the picture on the left, you see that they basically cut that trench just a hair wider than their roller. And that is so that your roller does not bridge the 2 sides of the hole. You're not getting the full weight of the roller on the patch material necessarily if that happens. So make sure that, again, you got enough material in there. You can provide for that slight crown, let it shed water. And then we know that over time, traffic is going to continue to compact that a little bit. Okay, so again, we're compacting this. Again, it's with a roller, and this is going to take several passes because it's wide enough that we have to go back and forth over it several times. You want to see that it's matching up in the edges and the corners. We don't want to see low spots on those edges. And the whole purpose here is just to really get it pinched down in there where it's really solid and becomes a consistent mass with the older pavement that was around it. If you don't have the big rollers, a lot of agencies don't, you can use whacker packer types or some walk behind type compactors. You can even use a hand tamper, like the things you would use in your yard. You can get from Lowe's. It's like an 8-inch square metal plate on a handle, and you can use that. But we need to do something that provides a significant amount of compaction to get this stuff tight, and we want it to stay where we put it and not have traffic pull it out. And what else can we do to make that patch better? Well, number one, we can do our patch work on a nice, clear day. We want to have that best case scenario, which is going to be a clear, warm day, moderate weather conditions. If it's too cold, it's going to be hard for that cold mix to really stick to the parent material. If it's wet, or even if it's damp, icy, any of that, it's not going to stick. And if it doesn't stay in place, it didn't last long, it cost us money and did not give us a lot of good. Again, if you can use hot mix rather than cold mix and coordinate that with something else that's going on in your area, wonderful, do that. That's going to help us make it a little bit better. Make sure we crown that surface, and then also at the edges of that hole, we want to just slightly overlap. When we pinch this material down into the hole, there is an intersection all the way around the edge where we cut, where we have the old material that butts up against the new material. That is an intersection that's very likely to take on some water. It is, I guess you could think of it kind of like a crack that does allow water to seep in. But if we're able to overlap that just slightly and we're letting water shed, maybe the water moves on and doesn't try to get into that intersection. So remember, water runs downhill, so we have to create the geometry that's going to make water move away from that sensitive point. You can also add crack seal material around the edges, and that's a great technique to keep that from being an opening that allows water to get in. And then over the top of it, you can even waterproof the patch by placing some fog seal. If you do that, you'll either have to keep it closed from traffic for a little while, wait for that to cure out, or you can dust it with sand to make sure that traffic tires don't pick any of that material back up. All right, at this point, do we have any questions that have come in?
Yes, we have had one question that's came through so far pertaining to aggregate. Why is the smaller aggregate preferred for patching?
Okay, good question. The main thing is if it's too big of an aggregate, it's more chunky, it's hard to get it smooth in a small space. And so most of our pothole patches are very confined areas, and the finer or the smaller those aggregate particles are, the smoother we can get it. Fine-grained mixes are easier to do hand work, and we typically have quite a bit of hand work that we're doing to get this smoothed out.
Okay, and we've had one more just come through. What are your thoughts on T-grinds for patches? We typically require them.
Okay, I'm not familiar with that terminology. Maybe you could type in a description of what the T-grind is.
The profile of the grind looks like a T.
Okay, where you kind of have a notch. Yes, okay, so what would be happening there is we have the primary part of the hole, and then at the edge, you come up and then tee out from that. So you kind of have a lip. What that is going to actually do It's kind of the same thing as overlapping the mix at the top, but it gives the edge of that pothole a little bit of a reservoir to collect that mix. I think that is a great technique to help. It's not going to confuse the water. It's still going to find a downhill spot, but it's going to give you a little bit more of a stair step to hold in. It's going to create that ability to put the lip on the edge, and then you can still overlap that at the top. But that T-grind is a way to be able to do a deeper patch and then make sure that we're not creating an opening at the top that will go all the way down through that structure. Yep, that is a good idea.
All right, great questions. I believe that is all we have at the moment.
All right, very good. Well, we will move on and next talk about deep patches. These a lot of times we call dig outs, and this is for something maybe where we have severe alligator cracking, which on a lot of roads, it's not just cracking. At that point, we've allowed water to get down into the subgrade and maybe even pumped out part of the subgrade, but we're losing mass of our foundation. So we're losing material, and there's usually a rut and a lot of cracking. The rutting phenomenon means that the surface is now got a depression in it, and by flexing that too much, you're actually also causing more cracking in the surface. So it all kind of works together and it's all falling apart. So we need, especially if we're going to do an overlay, we need to fix those problem spots before we try to cover it up with something else. So when we have a failure and it's pretty deep, we've got to get down there. If the deeper the distress, the deeper the fix has to be. And it's going to be easier to access that point before you put more stuff on top. So don't just cover it up and assume that that new overlay will bridge those problems. They might for a period of time, but 99% of the time, you will see those reflect back through. You'll see them come back. That's not what we want. So any of those soft spots, that type of thing, remember our strategy here is to dig at least 50% deeper than the distress itself. So if we look through that pavement structure, we might cut cores to figure that out, or we might just start digging. But when you see distressed material, keep digging and then go beyond that. Again, you've got to use some judgment of when does it make sense to quit digging, because we can only go so far. But when you dig through the pavement surface, you dig through the base material, now you're down into the subgrade. Okay? We want to make sure that we're replacing that with something better. For whatever reason, there's a problem in this location. A lot of times it's water. We might have an underground spring. We might be in town and have maybe a water line or a hydrant, and there's a leak close by. That can soften that subgrade and create this scenario. So when we put it back together, we want it to be stronger than it was before, because there's something in this area that's more of a problem than in other spots. So then we're going to put that material back in multiple lifts. So anytime we have more than about 4 inches of depth in our pothole patch, we want to make sure that we're putting it in layers, and that's going to help us get better compaction and have something more substantial to withstand whatever problem is already there. So what's happening here is we've got this structural issue, and we need to dig out deeper than what was there. So if we have something that's already got depressions, it's got cracks, we see those cracks actually go down into the base layer, the subgrade is deformed, we want to replace it with a stiffer material. When you look at a pavement structure, we get what we get with subgrade. It is whatever it was made of. We can do some modifications to that, but generally we try to work with what we have. But that means that what we put on top of it will have to be a stiffer material to withstand that weakness. And so we'll have some level of stiffness with our base, and then the asphalt mixture on top will actually be the stiffest layer. Well, the thicker it is of a particular material, the more stiffness we're going to get. So that's why we're going to go 50% deeper than the distress. And then we're going to put that back, not with the subgrade, but we're going to put in however many inches of base material. And then we're going to put asphalt on top of that. So if you look at this left side as being the original pavement structure, the right side as being the patched pavement structure, we've got a lot thicker section of our base aggregate, and we have a thicker section of asphalt. So that has improved the structure over all of those layers in the entire pavement scheme. So we're adding structure, we're adding capacity to what the pavement can stand in that location. Again, it's a temporary material, it's a patch material, it's not going to last forever, but by thickening those sections, we're definitely giving ourselves a better chance at having success. So looking at something like this, we've got a section that's been cut out. We're going to add that material again in multiple lifts, no more than about 4 inches at a time. And that gives us the ability to provide the maximum compaction with whatever compaction equipment we have. So we put that in, do one layer, do another layer, and continue to work our way toward the surface. So here we're compacting that base that's been added in. And then at the end, we've added in our asphalt material, and we're going to get that compacted, get it nice and smooth. And then hopefully that has a very long service life. All right, now smoothness is something to think about. And again, I said it's kind of an art to being able to shovel the mix into a hole. It doesn't sound like a difficult thing to do, but how evenly you can place that material in the hole initially has a huge impact on how smooth you can get it after the fact. So the smoothness depends on what lies beneath. So when you dig out, try to dig out to a consistent elevation. Don't assume that traffic will smooth it out for you. That might happen. Most of the time it really won't. And then don't skimp on the patch that's going to be overlaid soon. Make sure that whatever you do is going to last long enough to withstand traffic until you get to that overlay time. Okay, so looking at what happened here, this was a throw and roll project. And you can see there's a depression, kind of where the arrow is a low spot. And then on either side of that, there's a higher spot. So if you hit that with your car, it's going to feel very bumpy as you go across it. So that is really just a function of how much mix was in each location. I would say there's a big shovelful that got thrown here where this hump is. And then on the other side of the arrow, there was probably a big shovelful there. If you have a consistent amount of material, when you compact it, you should have the same density and the same support for your traffic. Okay, now at this point, I'm going to have you type some things into the questions pod. So these are pictures of what do you think is wrong. So look at the picture, and I'm going to give you a minute or so to put your thoughts together and enter that into the questions pod. All right, very good. So we've got comments that the removal limits they weren't sufficient. They didn't really cover the entire cracked area. The patch didn't go far enough to finish covering that base failure. And what's there is showing some signs of alligator cracking. Okay, so that area could have been larger, maybe some extra compaction there. So if we put that arrow, you can see this is the area that's cracked. So a couple of things here. We talked about how making sure that when you cut, you do encompass that entire area. But I will say that one of the things that can happen is that when you go in to cut, it may have been okay then, it just happened to be weaker. A lot of our cracking actually starts at the bottom of the pavement layer and works its way to the surface. So it is possible that you may cut in an area that looks like you've encompassed all of the cracks, but there are some cracks that you don't see at the surface, and those could have already been sort of brewing in the background. So we placed the patch, and then this area was a little bit weaker. And also, if you scar that edge material using power equipment as you're trying to dig out that patch area, sometimes that can start some cracking in an area. So things that can happen, but again, if you can completely encompass an area, go ahead and get outside the limits of that distress. The other thing you will notice is over on the side, there's a notch, and anytime you have an interior angle and a notch, there's a good chance that we're going to see some additional cracking, and that's exactly what's happened here. All right, your next one is to check out this photo and see what you think is wrong with that. All right, good comments coming in. Yeah, the compaction is an issue. It's very uneven, but what's happening here is this is a very minimal method. They actually came in and cut a square area, which was something that you can do that's a little better quality patching, but their compaction method was extremely minimal. So this was a throw and go. They had a truck, it was a dually, and they went back and forth over it, I think twice, maybe 3 times. And you can see they missed. There were some spots that were missed. So we have these little fins of mix that stick up. They weren't compacted at all. It seems like something that would be pretty simple, but you got to get those tires in exactly the right spot to completely compact an area. So you can see it's pretty easy to miss some spots, and if they get missed, they're sticking up, they're not compacted. Very rough patch there. I do see one comment, is this the guy you saw on the truck throwing the patch mix? It is actually not the same scenario, but maybe in that same arena, yeah. So good comment. These are rubber tires for compaction. One thing about using rubber tires for compaction when you have 2 tires close together, like with a dually or maybe a pneumatic roller, is that you do push the mix laterally in between those tires, so you have the weight that pushes down. It does kind of knead it into a lateral and kind of all directions, pushes in every direction. So we're trying to get those particles to turn and orient themselves where they're going to pack a little bit tighter. Obviously, we pushed some of them sideways maybe, and I would argue that some of them even went up higher than the original mix was placed. But yeah, we need even compaction, and especially if you've gone to the trouble to do the extra things like cutting the square shape, getting outside of that area of the stress, and then we end up with this. I think finish it, go the extra mile, do the extra things that you need to do for quality compaction as well. This is what traffic's going to see. Yes, traffic will knock some of that down, but it's still going to be a rough patch. Okay, here's another one for you. What do you think's wrong with that one? All right, good comments coming in. The shape of this, number one, we said that we need to have 90-degree angles, and you can see right there, there is a weird notch with no real explanation for that. Also, you can see in some areas along the edges, it looks like the patch material is kind of sunk down, and we may not have a crown. It's hard to tell from the angle of some of the pictures, but if you were able to look at that up close, you would see that there's not enough material there to really provide that water shedding situation. Now, in terms of the shape, that's the most obvious thing that jumps out. We are definitely going to see cracking in that notch. That is even smaller than a 90-degree angle. So there's almost zero chance that we can go very long without seeing some additional cracking that occurs in that space. Now, personal opinion, can't verify this at all, but the street where this patch is next to a sorority house, so it's possible that the workers were distracted. Don't know, can't really make that claim, but it is a possibility. All right, and one more. What is wrong with this picture? All right, looks like a pretty good consensus here that we don't have enough material in the patch. So when you fill that space, you want to overfill the hole by about 20 to 25% so that you have room to compact and still have enough material that we're going to shed water. Well, water is going to automatically go to the low spot, and this definitely looks like a low spot. So we're not really preventing this problem from continuing to happen, because this is a location where water is going to sit. The other thing that someone has commented on is right around in this middle section, you can see different textures in the aggregate. So we talked earlier about having small size aggregate on our patch material so that we can do some hand work and get that nice and smooth, and not using the teeth of the rake, because that will drag out some of that larger material. It looks like they may have raked, and right here on the kind of the top left side near where the cut happened, it's very tight. So that was the smaller particles that were in the cold mix. And then out here more in the middle, you can see a larger texture, more a little bit chunkier look to it. So I think that's where some of that material was raked, and we pulled some of the larger particles in, and they're conglomerated together in one area. So we don't have the same texture all the way around. And whenever we have those larger particles right at the edge, right up here in this top corner, you can see a little bit of that coarser texture as well. It's harder to get that compact tight up against the edge of that corner. So we've got a low spot, we're taking in water, it's working, but it's not great. It's probably not smooth at all for us to drive over when we go down that street. And then we've chewed up the edge just a little bit. This is not terrible, but it is kind of a close-up example of some things you might see when you get your equipment in there and you can chew up that edge. That makes it hard to compact evenly against the edge, and you may have some spots left over that allow water to infiltrate. All right, very good. Thank you for your participation in that little session. All right, and then I wanted you to have this, not so much for me to read over the whole thing, you can read and look at this later, but in these slides, these are just some troubleshooting tips. So if you notice any consistent issues in your agency when you go and do pothole patching and then you see the same problems coming up, here are some of the things that you can look for. So if your patch material is coming loose, make sure the hole is clean and dry. Make sure you did all of those things that are best practices to make sure that we're getting a good bond between the old and the new material. If you have an uneven surface, a lot of this is going to be related to compaction. There is also the potential, if you're using hot mix especially, that temperature differentials make that happen. Or if you're using hot mix and didn't really have the ability to maintain that optimum temperature, then we're going to have differences in density depending on the temperature of those different chunks of mix. So if we have material sinking, make sure you're filling it properly, compacting it properly, forming that crown. If you form it and compact it some, and you make it look really pretty, but it's not really tight, you're not getting a high level of density with that shape, traffic is going to continue to compact it, and it will be a different shape when you come back in a couple of weeks. Fleshing, that's where we have binder that's coming through to the surface, so it looks kind of wet, has a little bit of that tar look on the top. Maybe you put too much tack coat. A number of things could happen there, and some of that can be related to the mixture itself. All right, any questions at this point?
Okay, we did have one question come through a little earlier, and one thing I got to say about, I think my favorite comment on all those pictures you posted on what's wrong, the favorite comment I saw was everything. So I thought that one was pretty funny.
Yeah.
But we got a lot of good responses on that. Yeah, one question we got a little bit earlier is based off your experience in Arkansas, how long do you typically see patching last?
It is a really wide variety. I would say the majority of the throw and go type of patching, 3 months maybe. So unless you're doing like the complete cutout, now some of those, semi-permanent complete cutout on a smaller city street that's not getting a lot of heavy traffic, those can last for years. Those can be very, very good. So it really does run the gamut. And I have to echo, what the slide said earlier, the more effort you put into it, definitely the longer it's going to last. So following those best practices keeps you from going back to the same places over and over. So there's a strategy to that. And I think if you keep records and you kind of balance that out and pay attention, here's how much effort we put into this certain scenario, and here's how long it lasted. Compare that to somewhere you do the throw and go or the throw and roll. How long did it last? Do the math and see which is the most efficient and overall the cheapest for you to do. Not just cheapest in terms of materials, but cheapest in terms of having to send a crew back to that location how often. Okay, if you have maybe a route that has some big trucks and you're doing throw and roll, arguably you could go a few weeks and it's back. And it depends on the weather. Springtime and wintertime, I would say, are probably the worst. And you probably, I know most of y'all, I think, are from Arkansas. We've got some from other states that are tuning in as well. But we did have a spell this winter. It was very cold. It stayed cold for a while. But we tend to see a lot more swings in the weather. We'll have some freezing temperatures for a few days, but it's not going to stay below freezing all winter long like it might in Minnesota or Canada or something. So we see more of those fluctuations of freezing temperature. A week later, it's 70 degrees. A week after that, we're back in the snow and ice situation. So the snow and ice is really going to wreak havoc on our roadways. And we saw around Little Rock, a lot of the interstates had some big chunks pop out. There were some massive potholes that created some real safety issues over on the east side of Little Rock and then also in the southwest. That's kind of a big deal. So the more traffic you have, the, I guess, higher profile roadways where you get more press if something goes wrong, kind of address those with a more substantial fix. And then the ones that are more local streets, don't have as much traffic, you can probably get away with some of the less intensive methods of repair.
Okay, great. Well, I believe that is everything we have for now.
All right, well, we're going to touch on a few other types of patches and then we'll move on to crack sealing after that. We'll talk about edge repair, and this is important because we need some lateral support to really make everything hold together. So when we have these smaller city streets, county roads, we don't often have paved shoulders. So if we're bringing up some type of a crushed aggregate material on the side, a lot of times that wears away. It's going to run downhill after a rainfall. And you see something like in the picture where there's a drop off at the edge. So safety issues there, but also potential for cracking. When we have narrow lanes, especially, I know a lot of our county roads are not super wide, but they do handle a lot of large trucks. So logging trucks, chicken trucks, dump trucks, hauling all kinds of things. And so you have those heavier loads, dual tires, big trailers, it's harder to track. And so they get off right on the edge. And if we don't have that lateral support, there's definitely the potential for a lot of cracking on the edge. When that continues to happen, we've got to fix that. So we're going to use the same principles as those other patching methods, but we've got to consider that shoulder type, the condition, and then also think about drainage. Drainage is the biggest feature that is going to create issues here at the edge because we want water to get off of the pavement and we have to maintain that drainage path to make sure it's moving away from our pavement structure. All right, so next slide right here. This is one of the things that we see a lot. And so talking about those bigger haul trucks that are carrying all kinds of things on our county roads, when you start to break the edges, you end up shrinking the width of the pavement. And if they're already narrow to begin with, we're just making that problem worse. So when we have those edges that are pretty chewed up, we don't have a nice solid surface for that outer tire to be rolling on. And especially a big trailer that's going to cut the inside of a curve, you might even look at making the lanes in that curved area on the inside of the turn, make that a little wider. It's a little bit of a help for safety, just for being able to navigate and stay in your own lane, but it does help with some of those longer trucks with the big trailers. Another thing we might see for local roads, city streets, is turn radiuses on some of our local streets. and you get a little broken spot, and that just continues to eat away. And what do drivers do? They make the shallowest turn possible. They want the larger turn radius, although the pavement may not actually be there. We can probably save a lot of maintenance activities by going ahead and making a larger radius at those entrances, just to keep those tires fully on the pavement, not on the edges, breaking that down. We also see some breakage at the edge of the pavement anywhere we have trash trucks, mail trucks, delivery trucks that are stopping at certain places. We know that slow and standing loads are going to create more damage to the pavement. And that's exactly what's happening with those vehicles that are going a little bit and then stopping, a little bit and then stopping. So you'll tend to see some more exacerbated deterioration signs at those particular locations. And near a curb, sometimes we have some extra deterioration because we may have a concrete curb that's very stable, and asphalt is flexible, so it moves a bit. And if we have an expansive soil underneath that asphalt that's moving around on us, we've got everything able to move except for the curb. So we end up breaking the asphalt and kind of piling that into the curb. So not only do we have deteriorated pavement, we also have kind of botched our entire drainage system over there at the curb. All right, so looking at this unsupported edge, if you look right over here, we see some early signs of deterioration. It's not bad, it's fine. The roadway's intact, but you see a lot of grass on either side of the road, and here, there's no vegetation. That's a sign that we've had some tires over on the edge, maybe off of the edge of the road, that's creating a load at that unsupported edge. Over time, we'll start to see a little bit more of that break up. And if you look closely in the picture on the right, you can see some cracking right here in the stripe. When the stripe was originally placed, it was not this close to the edge. There were a couple of more inches of pavement out there. That's gone. And so now we're starting to see some cracking inside the stripe. And that will continue to move toward the center of the pavement. So we're losing our effective support at the outer edge of the pavement lane. So right here we see some things. Over here we see some breakage. We see that crack moving in. All kinds of things are going wrong. And again, as soon as you start seeing these types of things happening, they're going to start happening faster. That deterioration curve really kind of ramps up as we see those cracks make it all the way through the layer of pavement. Another type of patch is a skin patch, and this is where we're just kind of covering up a whole section of pavement. Maybe there are quite a few cracks that we're trying to cover, but it's not really paved. We didn't place it with a paver. We're just going to put out some cold mix, maybe hot mix, and then use a blade to come in and smooth that down and then roll it to keep it in place. So we're placing that patch on top of the existing surface to create a new smoother surface. But again, it's not really a pavement layer, so to speak. Okay, so for the materials and equipment with this, we need our patch material. Again, a fine graded mixture, no more than 1/2 inch top size of an aggregate. Hot mix is best, but there are a lot of emulsion products that also work and a little bit easier to work with. So we might see cold mix. Cold mix is not going to last this long though, especially through a winter, because this is such a thin layer. It's hard to get it to really bond to what's underneath it if it's too thin, especially. Then we're going to add a tack coat, 0.1 to 0.2 gallons per square yard. That's going to help us glue those layers together because we do know there's the significant chance of delamination here. And then we want a roller on it, but we want to make sure that this is either a pneumatic roller or a steel wheel static roller. I do not want to use any vibration here. That is such a thin layer that we're putting on top. If I add vibe, what's going to happen is I'm going to start to break or put some micro cracks into the underlying structure, the main pavement. Definitely don't want to do that. Okay, so placing that patch material is going to involve spreading that out, and we have to make sure that we get a minimum thickness. It's very thin. it looks like just a bit of a coating, but we do want that to be at least 2 times the largest aggregate size. So if I am using something with a 1/2 inch top size, I need it to be at least 1 inch thick. I don't want any single particle to be as thick as that layer. Okay, I want it to have some room. Each particle should be able to roll around, move a bit to really seat with the other particles. And if it's too thin, it doesn't have a chance to do that. It's a good idea to first roll with a pneumatic roller and then finish with your static steel. You can just use the static. And then it's also a good idea to fog seal this before wintertime, particularly if it is a cold mix. The fog seal will kind of make it a little more impermeable and just give it that extra layer of coating to protect it through that season. Here's another example of one, and you can see how in certain areas we do have that delamination. We have what's almost considered a pothole, but this is just a patch that was placed, and then we started to see some of that crumbling. All right, and then injection patching. This is something that I know several agencies have a patch truck, and it's basically something to reduce the number of people that have to do the work and also to speed up the process of filling these potholes. So advantages, it's fast, it's fairly effective, it's better than throw and roll. 1 or 2 operators can get a whole lot done in one day. There are some disadvantages. It requires the special equipment because you do have to buy the device. So there's cost, and it's still a temporary patch. So there's nothing magical about it that makes it a much better product necessarily, but you just get more done in a shorter amount of time. So the way that it works is that we have a nozzle on this truck, and we've got all of the materials also included within the tanks on the truck. So the first step is that we're going to use that nozzle and blow air onto the roadway. That's going to get rid of our debris, clean out that hole. It's also going to dry out water that might be standing. Then we're going to apply a tack coat. Again, that's going to happen through the nozzle. So just a little bit of that tack material to the bottom and the sides of the hole. And then the nozzle is going to be used to blow that asphalt and aggregate mixture to fill it in and fill that all the way to the top. And then we'll have a layer of just aggregate, kind of finish coat on top to keep it from sticking if traffic, because we're going to do this quickly, we're moving on. So traffic is still on this roadway. I don't have to roll it. It's a good idea to drive over it as you pull away, but you don't have to. The injection gives a little bit more force, which substitutes somewhat as a level of compaction. So fancy truck, cool stuff. One negative that I would say, some folks have bought one, they loved it the first season, the second season they couldn't get it to work. It's very easy for things to get clogged. So when you put this away for the winter season, make sure it is cleaned out to the utmost of your ability because you want it to work again in the spring. You don't want stuff to get, asphalt kind of gets nasty and we don't want it sitting there and clogging nozzles and all of that. So. All right, some other alternatives, probably not feasible for most of us, but I think it's cool stuff, so I wanted to show you. There are some infrared heaters they can be on trailers or attached to a truck, but pretty cool things where this whole heater panel goes in and heats the existing asphalt so that when you put your patch material in, you're actually getting a heated bond, and that eliminates some of the seams around the edges. This can help rejuvenate some existing pavements. It can mean that you can do some pothole patching in colder weather than what you would normally be able to do. So the northern states, I know Canada does quite a bit of this, and they can do pothole patching year round and have a decently patched area that will last. So the heater panels go along, it's propane driven. So these heater panels go through and heat up just in front of where you're doing your patching. This one is actually configured for longitudinal patches. So it is heating it up enough that they can scarify what's there. And you can see they're working in the wheel path. You can also add some rejuvenators, add a little bit of new material to that. Everything's warmed up. You put your new stuff down, roll over it, and you really don't see the seams. You'll see a little bit of a color differential, but it helps reduce the potential for quick deterioration because it's harder for water to get into those seams. So neat stuff. All right, any questions?
Okay, we've had one quick comment that I'll point out, and then we have had a couple questions come through. Rod, who's from Iowa, says most patches only last from snow event to snow event. Even if we leave the patch low, the plows freezing will pop the patch out. So just thought that was interesting and didn't know if you wanted to comment on that.
Yeah, so weather is a huge factor on all of that. So patches, when you have winter seasons, patches typically are going to expire at that point. If you're far enough in the south that you don't have those extreme weather events, you can probably make it a little longer, but yeah, totally agree.
Yep, and that was referring to with cold mix. We did have a question, a question from Tammy. What is a fog seal?
Okay, so fog seal is actually a very thin emulsion product that is sprayed, just a light coating. There are some little spray rigs that you can do this by hand for patches, but fog seal is something that can be applied to an entire roadway surface. And we will actually talk about that next week in some of our other treatment options, but that's something that we can use on a pavement to prevent or slow down the weathering process. And some of those micro cracks that happen from oxidation, it's going to be really helpful there.
Okay, and we've had one more question come through referring to for infrared heaters. Do you know if you can add cold mix to filled material or bituminous oils, tar, tack to help rejuvenate that asphalt?
Yes. Now, typically on that, I think that you can add some cold mix, but they typically recommend that you're adding more of the liquid because the older asphalt that you're tearing up, that kind of becomes your aggregate. So the rejuvenators, you can add more of the oil, and the rejuvenators, the chemical in it, it's going to help kind of plump that up and try to reverse the stages of oxidation. There's a lot of chemistry to that, but some of those products are really good. So typically we're going to see what's there kind of serving as the aggregate. And then rather than adding cold mix, we're going to add more liquid to that. Now, if that patch has sunk in, I have seen them add an entire mix to the mix that's there because we're trying to increase the volume of mix that's in that location. But if it's just cracking and it's still relatively in where it's supposed to be for the cross section, you don't need a lot of more material, but you need more of the oil to help stick it back together. So yes, absolutely more of that tar, oil, tack that will help rejuvenate that. And it makes it blacker, so it looks a little newer. Not that the color is important, but the important part is that it does have that newer, less aged look to it. So we're buying it time that it will last longer in the future.
All right. Well, I believe that settles everything we have at the moment.
Very good. All right. So let's move on to crack sealing and filling, and we'll look at that a little bit. So quick poll question for you. Does your agency perform crack sealing? Yes, no, or I'm not sure. All right, those answers are coming in overwhelmingly yes. There are just a few said no, or they're not sure. So I'm glad to hear that most of you are doing the crack sealing, because a crack is an opening in the pavement that allows air, water, and other grit and incompressibles to get into that space and cause all kinds of problems. It's a very small location. So in terms of area, it's a tiny spot that can create deterioration over a huge area. So we definitely want that to be minimized. All right, I'm going to close that poll. We will move on here. So cracking in terms of fatigue typically happens as bottom-up cracking. So if you imagine that your asphalt layer is a Rice Krispie treat and you put a load on top, while you hold those edges in place, it's going to bend downward. So you're putting that load on top, it presses down, and when that happens, it's going to pull apart at the bottom of your Rice Krispie treat. Okay, the top squeezes together, the bottom pulls apart. So the beginning of the crack is happening where we can't see it. By the time we see it at the surface, it's probably much worse down underneath. So it's kind of sneaky, gets at us. There is also a phenomenon called top-down cracking. And this is something that's, I would say, traditionally was not an issue. The last, say, 15 years, we've started to see some more of that. Some of that's attributed to some of the larger trucks, the super single tires, that kind of thing. So a lot of theories on why this is happening. But in this case, we're actually pulling apart at the top of the layer instead of the bottom. That's a good thing because that means that the problem doesn't go all the way through your pavement. Now, how do we know the difference? Usually, you just need to cut a core and see what it looks like down there. Now, when we have a crack, that means things are moving. Something broke, and so there was a movement. We need to figure out how that's happening, how much of that is happening. So working cracks have a lot of horizontal movement. So when those pieces separate, it's going to change, and that's typically due to moisture damage, temperature, and we're going to see an annual horizontal movement, kind of a shrink and swell, if you will, of those pieces of the mat of more than 1/8 of an inch. So things are changing shape, changing volume. The temperature is a huge factor. Cracks will be more narrow in the summer because if you think of these different sections of the mat as, say, a ribbon, and if that ribbon gets really cold and it shrinks, that means there's more space between it and the next section. In theory, our asphalt shouldn't be in sections, but once it's cracked, of course it is. But then in summer, those pieces kind of swell back up, so they get closer together. And we see that that change is going to be more obvious with working cracks between the seasons. So this is going to happen typically just with transverse cracks because our pavements are long ribbons. Those transverse cracks are going to be where the breaks happen that have enough volume in that other direction to really change in length. Vertical movement is sometimes a factor. We don't really consider that in determining if something is a working crack, but it certainly affects the performance. So we see things move apart in the winter, and then we see them close back up in the summer. But the other thing is, once we have that crack, there's a pathway from the atmosphere down to under the pavement where water goes in, air goes in, and particles can come back out. Those particles being the base or the subgrade. Now, once I lose any amount of that material underneath, I no longer have consistent support under that pavement section. So if we look over here in the bottom right, the red lines are cracks. And once you start to have pumping through here, we're losing a lot of material. We no longer have that good foundation, and we're probably losing some parts of the bottom of our pavement layer even. Now, what's happening here is that we have a load. This tire over here is moving toward the right on the screen. And so once we've lost support under the edge of this portion of pavement, it can move down. And then we hit the edge of that next section, and you can hear that, and this happens in concrete too. So if you drive down a freeway that's got the concrete and you hear ka-chunk, 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 those are planned to be very evenly spaced. We don't plan that for asphalt. It's not supposed to happen, but it does. So they're not evenly spaced and you don't really have the rhythm to it, but the same thing is happening. So then our tire moves across that intersection and we see that first portion pop back up, the second portion moves down. So as we have repeated traffic, that's just going back and forth, and you can see that action, that vertical change is going to pump more and more of that subgrade material up through the surface. We're having more loss of support underneath. So what do? We're going to seal those cracks early to prevent that whole thing from happening. Now, when we crack seal or fill, then we're going to be looking at anywhere from 1/10 of an inch crack opening up to 1 inch. And that's pretty good size crack. But the method that we use is going to depend on what caused the crack and what kind of activity is happening. So do we want to seal it or fill it? Well, what caused it? Do we have structural issues? Are they working cracks? What is that crack width? Do we have edge deterioration? Mainly crack filling is just that. It's just a filler. We're going to use that for weathering, those non-structural types of crack, the ones that aren't moving. This is going to be a lower cost, kind of a lower impact solution. But what's our point? Our point is to keep water and air from getting into that structure, keeps incompressibles from entering that crack. I don't have to do a whole lot of prep. It's pretty cheap. So this is like the short version or the minimal method of getting that sealed. But if that's all you're trying to accomplish, then that's good. Our filler material has to stick to the edges of the pavement to be able to adhere to those cracked faces, resist abrasion by traffic, and usually fillers are going to be a hot applied rubber type material or polymerized asphalt. Every product is different, so when you're using it, make sure to follow your manufacturer's instructions. Now, sealing is a more substantial material, so I would recommend, if you're going to have an overall policy for how you treat things, just use a crack seal, call it good. For this, we need to make sure that we're thoroughly preparing that crack, and we're using some specialized materials. Usually they're hot applied, and by hot, it's even hotter than like an asphalt mixture. So it's going to be up closer to 400 degrees. There are some cold applied that are silicone based, but they're not as abrasion resistant, so they don't last as long, and they're more expensive. So typically not something that you would choose unless you had a very specific reason for that in a certain location. Now, the sealant material has to be, like I said, a more substantial type material because it's got to flex, stretch, move. So think of it as Stretch Armstrong, and the elastomeric material needs to be able to stretch 10 times its normal dimension. So that's a pretty good amount of flex. Remember, asphalt is flexible, and the sealant material has to move with it. So if it's a working crack and it's moving season to season, my crack sealant has to also be able to handle that. So it has to stick to the wall of the crack. It has to expand and contract with our temperature fluctuations, stretch and compress without rupturing, and then still withstand traffic. The process is a whole lot like what we did for our pothole patching. We're going to clean that crack out because we need to have that good adhesion between the old and the new material. Hot air blasting is probably the best option. You can use cold air. You can also use sandblasting, but the problem is after you've sandblasted, then you have to clean the sand out. So you end up using some type of air blasting also. Then we're going to place that material using whatever finishing method and applicator, and that's typically going to be manufacturer specific because the nozzles, the openings, everything is going to be specifically modeled for the product that you're using at a particular temperature. We're going to use a squeegee to make sure that we kind of strike that off and make it look nice. And then if we have something on the surface that can be picked up by traffic, you want to make sure to use a blotter coat to keep that from happening. That would be like a clean, dry sand, something like that. Now, some of the hot rubber or the modified sealants, they're going to cool off pretty quickly and not be as much of a problem. But again, everything is different. So use your manufacturer's instructions and follow those very closely. You do not want to broom that though, because it will kind of pull that out. Now, when we fill those cracks, we want to fill it all the way up to keep water out. We don't want a low spot. But one of the techniques is called a flush fill, where we force that material into the crack, then we strike it off with the squeegee. That tends to leave us with just a hair of a low spot, which will still, it will hold some water. If you don't have any gaps, then that's okay. But if any portion of that pulls apart, that could be an issue. So that's probably not optimal, but it is an option. The other alternative would be to cap it. So we put in enough and then we overlap those edges so that it's capped. So we're forcing that material in, covering it up, but when we leave that little bump, that makes a noise, and people usually don't like it. So the recommendation is kind of an in-between of these two. Where you fill it, you have enough to be capped, but then when you squeegee it, you flatten that out where you don't feel the bump as you're driving over it. So capping is not recommended. It's too rough, can be noisy. The Band-Aid is kind of the happy medium between all of the options. So, and then one other caution, if you did use that silicone type product, it typically is not durable enough for overbanding. Now the reservoir method, what if we have larger cracks and they move a lot, or they're really big, open, they're random, and really for asphalt, we don't see nice, clean, straight cracks. They're gonna wind around and kind of do their own pattern. So we've got to be able to do something and cut that or route it out. And instead of trying to force material down in this irregularly shaped spot, we're gonna create a bathtub. So we're gonna route that out, use a random crack saw, something, again, it's kind of an artwork, takes some skill, and you're gonna have to route that out and create a little bit of a basin to put your sealant material in. And we're gonna fill that in with material. We're gonna strike it off either flush or overbanding, but that takes a lot of material, which is gonna get expensive. So if we have more than about an inch of depth of our sealant, we can use some type of a filler material. We can use sand, or we can use a backer rod to fill that in. That way we're only paying for the top portion to be the expensive stuff. All right, and then just remember, the more stuff you do, the more it costs and the more steps that are involved. Now, the most important thing I can tell you about crack sealing is that the timing is critical. You want to think about those working cracks and how they shift from season to season. So in the summer, they're really tight. In the winter, they're more open. So if you think about doing this during the winter, you're going to get more sealant into that crack. But then also, that means in summer, when everything pushes together, that sealant's going to bubble up out of the crack. So that's no good. In the summer, the cracks are closed. I can't really get enough sealant in those cracks sometimes to do any good during the winter months. So Papa Bear, Mama Bear, Baby Bear, Goldilocks kind of thing. Let's split the middle, and we're gonna choose to do this and have the best results during spring or fall. We wanna do it during dry weather to make sure we get good adhesion. And the optimal air temperature is somewhere around 45 to 65. That's air temperature. And that is probably going to be a midpoint of that crack width between the seasons. That way it can stretch a little bit when things open up, and it can compress a little bit when they close down. So we're right at that optimal midpoint, but make sure you don't do this during midsummer. And I think just because of the nature of our schedules and maintenance activities, sometimes that's what happens. But it's not going to last as long because you can't get enough material down in the crack at that point. Now, a lot of our sealant materials are emulsion products, which means they're going to cure out by water loss. And so it takes a long time for that to happen. So a lot of your manufacturers will recommend that you don't overlay for at least a year. Something that can happen with hot applied sealants is the cooling process. The manufacturer will recommend that you wait 3 or 4 months before you overlay. But what's happening there is we've got this material that's not totally cured. If you get it hot, it's going to swell up on you. We don't want that. So if you are getting ready to overlay a roadway, we definitely recommend that you do your crack sealing, get everything underneath the pavement fixed as well as you can to get a nice smooth surface to pave on. However, if you come right behind that crack sealing and you put hot mix on it, that is enough heat to swell that up, and sometimes it will actually swell enough to crack your brand new pavement. We don't want that. So you could use warm mix. It's going to be placed at a little bit lower temperature. That has worked for some agencies. The other option is to just be really proactive and plan ahead do your crack sealing in the early spring, and that way you can do your paving project in the summer. And that should be enough time to keep that from happening. Okay, what about other treatments? Everybody asks about, how can I keep reflective cracks from a deeper pavement layer from reflecting through to the surface? Well, that is the $64,000 question. Everyone would love to be able to do that. And this is especially important if you have a city street that's concrete. You're going to pave asphalt over the top of that. Those cracks or joints that are in the concrete pavement will eventually reflect through. There are some materials that can be used to try to slow that down, and you definitely can slow it down. I don't know of anything that's really magical for totally preventing that. So just be aware of that. But, the obvious thing to do is to fill that crack, do something to try to bridge it a little bit. All right, and then I've got a couple of slides here for you. What can you do in terms of troubleshooting? Well, some of the things that we see that are a problem, the sealant's bumpy or it's raised or it's too tacky. So make sure and look at those best practices. Check your squeegee. Those will wear out. They have to be replaced. So make sure and check those. And then I've got a couple of slides here, but we're about out of time, so I'm going to skip through that. This one as well as the next one. You can see there's a lot of crack sealant in both of these situations. My kids, when they were little, would say it looked like somebody drew on the road with a Sharpie marker. It does look like that. Is that okay? It's absolutely okay. It's not the prettiest thing in the world, but really we need to be concerned more about function, which means that we're trying to keep the water out of the pavement structure. And if looking like we drew on it with a Sharpie marker makes that happen, I am preserving the integrity of that pavement for a longer time. Okay. Again, not the prettiest thing, but it is functional. Okay. The other thing with that much crack sealing is it took a really long time. And when you're out in the road, you got to think about traffic safety, work zone, all of those types of considerations. And you are putting workers in a traffic lane for a longer period. All right, I think that covers the crack sealing. Have we had any last minute questions come through?
No, I believe that that is everything.
All right, very good. Well, thank you so much for your attendance. We do have, again, the part 2 of this webinar is next week. That's on treatment options. We're going to talk about fog seals, slurry seals, chip seals, all of the kinds of seals that you can use as a treatment option to do something more than just patching or crack sealing, but not all the way to an actual overlay. So kind of all those in-between things that maybe we haven't thought about before. It gives us a little more of an out-of-the-box thinking process on when to use some of those options. So that will be next Thursday afternoon, same time, same place. So feel free to register for that if you haven't already. That'll be Central Time, 1:30 to 3:30. And I believe that is all I have. So thank you so much for your attendance. And you should have an evaluation form pop up. So feel free to contact me with any questions. Let me know what you thought was good or improvements, ideas, suggestions to make this better. Would appreciate to hear all that. All right, thank you and have a wonderful afternoon.